All right. I want to talk through sequences of transformations because that's a topic that we didn't talk a lot about in class, so I wanted to kind of give you more information on how to approach more complex sequences of transformations before we go into the exam. So let's imagine that you've come to the conclusion that you have four different types of transformations happening. We'll say we have a vertical stretch where it's a times 2 situation, a horizontal compression, that's also a times 2 situation, a vertical shift, we'll say in this case is a +1, and then a horizontal shift that's also a +1. So on the vertical shift, of course, the +1 means we're moving up 1 in the y direction, and the horizontal shift +1 means that we're moving to the left 1. So, and we say we don't know what kind of order that we're in. So, what are our options? Well, the thing is, we have 24 different options of putting these four in order, right? We can do A, B, C, D, and we have all various options until we could go backwards, D, C, B, A, and we have a bunch of options in between. The important thing here is that even though we have 24 different options and order does matter, we don't have 24 different solutions. We actually only have 4 different graphs or functions that could come out of this. So some order matters, but some order doesn't. So there are only 4 different ways that it really makes a difference, and they go in these groups. You don't need to memorize these groups because we're going to talk about how these function when we see the equations. Okay, so let's say we have the original function. Right? I'm just going to skim through the different graphs that we're going to see, and then we'll talk more about it. So here's our original function. Okay. Then this is one version where we have all those 4 different options. Here's another version. You can see it's a little bit different horizontally. Here's another version. You can see that's moved vertically from the last one. And you can see that this is also horizontally different from black to purple. And then, of course, all together, we have these 4 different options. Okay? And you'll notice we have some different parentheses going on, but you can see that our horizontal changes, our horizontal transformations, are being where we're multiplying the x by 2 and adding 1. And vertically, we're doing the same thing. One thing to remember is that the horizontal only affects the horizontal, and the vertical only affects the vertical. So whether you do your horizontal shift first and then your vertical shift, or your vertical shift before your horizontal shift, that doesn't matter. So that's not important. The only relationships that are important are which of your horizontal things that you do first, or which of your vertical things you do first. So shifting before you compress, or compressing before you shift will give you different results, whether that be horizontally or vertically. But they don't correspond. They don't move across those 2 options. Okay, so we see our 4 different options here. And just as a reminder, the parts that are within the function, all right, that are changing directly with the x value, those are our horizontal transformations. And the ones that are affecting the outcome, the f of x, they're on the outside of the function, those are our vertical transformations. Now, here's how we can apply this situation. We always want to apply the transformation that's closest to the function first. Remember, we can do the vertical first or the horizontal first. It doesn't matter. but when we're focusing on one of those, when we're looking at horizontal, we want to apply the transformation that's closest to the function first, and then do the other one. So I'm going to rewrite this a little bit, and let's pretend for a moment, or what, we don't have to pretend, let's rewrite our 2x, or our multiplication transformation, the stretching and compressing. We're going to write that as t star, as the function t star. And our shifting transformation we're going to write as t plus. Okay, so star for multiplying, plus for adding, right? Okay, so I can rewrite each of these functions as a series of transformation functions that are transposed with our original f function. So one thing to note, if we look at the purple, let's ignore the things happening outside the function and let's first look inside the function. These are going to be our horizontal transformations. Notice that we have this x plus 1 inside the 2x function. So our plus function, our t plus, is inside our t star function, and both of those are inside the f function. Okay? So when we're looking at which one is closer to the original function, that's the t star. So in this case, we would want to do our horizontal compression first, and then do our shift, our horizontal shift. So notice the compression is closer, and then the shift is more removed from the function. So we do the compression first, and then the shift. Then if we look at the outside, notice we have this plus 1 is in parentheses, and then it's being multiplied by 2. So we have the function, then we add 1, then we multiply by 2. So here's our function. It's inside of our t plus transformation function, and that's inside of our t star transformation function. So the one that's closer is the plus. So in this case, we would shift first, and then we would stretch. Okay, and you can notice the difference here. If you look at these two between the purple and the green function, notice the inside is the same. So that means both of these cases, we have the star first, and then the plus. So that means we're compressing first, and then we're shifting. Okay. And if we look horizontally across these, our outside functions are the same. So in these top cases here, we're adding first, and then multiplying, which means in this case still we're shifting and then stretching. In the lower cases, the function is being multiplied by 2 first, and then you're adding 1. So our function, we need to do the transformation of stretching first and then shifting. And then internally, when we have the 2x plus 1, right, our x has been replaced by a 2x, and then that's been replaced by the 2x plus 1. So our 2x function here, our t star, goes into our t plus transformation function, and then into our function. So when we're talking about transformations, remember we go to the one closest first. So horizontally, in these two lower cases, not in the two lower cases, in the two right cases, we are going to do our shifting transformation first, and then we're going to do our compressing transformation. Hopefully that gives you a good sense. So if you have 4 different transformations, you really only have 4 options. Even though you could do it in 24 different ways, there are only 4 important distinctions. And those branch into whether you do the stretching or compressing before you do the shifting or after you do the shifting. And so since you have 2 options vertically and 2 options horizontally, you have 4 total options. And you may be asking, what about reflections? Well, remember, a reflection is just a version of a stretching or compressing. And so if you see that negative, you're going to look at the same thing. You're going to say, well, is that transformation happening next to the function? And where in line is it? And if this were a -2 instead, you could treat those both at the same time. You're stretching and reflecting at the same time. Okay? Or one after the other. It's not going to make a difference. Okay. So just to give one example, okay, so just try to reiterate what we've talked about. When we have these 4 options, and if we're looking at our purple function, our purple set of transformations, our new function, we notice that the b here, the horizontal compression, is closer to the function than the +1, than the horizontal shift. So since b is closer, you do that transformation before you do the d transformation. So you horizontally compress before you shift. All right. And likewise, the +1 is happening before you're multiplying by 2. It's closer to the function. So your vertical shift needs to happen before your stretch. So hopefully that gives you a good idea of how to approach these problems. Try a few problems like this using that strategy. Plug them into something like Desmos or another graphing calculator application, and see if your transformation order matched up with the result that calculator gave you.